Hey guys, it's Mr. Sheelan. I just wanted to go over for you guys, if you were at home, how to answer a couple of the questions here in this calorimetry worksheet number 3 worksheet. So on the back side, there are 3 problems. There's number 5, there's number 6, and there's number 7 that kind of cover things that we really haven't explicitly done before. So I want to walk through one of them for you so you know what to expect, you know what's happening, so that when, fingers crossed, you come back to class, we are a little bit better prepared for the lab that we're going to complete later on. So, okay, we're just going to look at number 5 here. So it says here, number 5, a 2.50 gram sample of zinc is heated, then placed in a calorimeter containing 65.0 grams of water. The temperature of water increases from 20 degrees Celsius to 22.5 degrees Celsius. The specific heat of zinc is 0.390 joules per every 1 gram by 1 degree Celsius. What was the initial temperature of the zinc metal sample? So the final temperature of both the zinc and also the water are the same. So what the heck do we do with this? We have to break this in half here. Okay, we've got to solve for 2 things. Okay, why do we have to solve for 2 things? Well, think about it. We are taking a heated sample of zinc, we are tossing it in water, and we have to figure out how much energy was gained in the water versus, and then use that number to say, hey, zinc lost this amount of energy, and here is what the initial temperature of the zinc was. Okay, so what does that look like? Well, again, first we're going to just start with solving with what we have with water, okay? Because again, we're taking a little heated sample of zinc, we heated it up, we tossed it in the water, we saw that the water's temperature increased from 20 to 22.5. We can determine just how much energy that the zinc lost, but the water gained by using what we have for the water. So here, we have a change in temperature of water of 2.50 degrees Celsius, okay? We have a sample of water here that's 65.0 grams, okay? We know the specific heat of water is 4.184 joules per every 1 gram by 1 degree Celsius. We just don't know how much heat in this case was gained. We don't know the heat gained, okay, in the water. So we just solve for the heat gained by the water. So it'll just be the mass times the specific heat times the change in temperature. So then Q is going to be 65 times 4.184 times change in temperature, which was 2.50 degrees, which is then going to give us, oh, I gotta pop this in my calculator. Which is going to give us here a change of 679.9 joules worth of energy changed, okay? So again, what did we just calculate right here? This is the amount of energy that the water just gained after a heated sample of zinc was tossed in. Okay, why do we care about this? Well, we can actually use this to say, well, in our sample of zinc, zinc lost, so a negative, it lost 679.9 joules worth of energy. Okay, so it lost that amount. Okay, what else can we say? Well, we know that the specific heat of zinc is 0.390, okay, joules over grams per 1 degree Celsius by 1 degree Celsius. We know the mass of it is 2.5 grams. Okay, what do we need to know? Well, we know that the final temperature is 22.5 degrees Celsius, but what was the initial temperature? How hot was this stuff? Well, we've got how much heat energy was lost. We've got its specific heat. We've got its the amount of grams of the sample, the mass of the sample, and we have the final temperature. So we just need to solve for the initial temperature, which is going to be a whole negative multiple here, which is going to be Q over CS times M plus TF. So that's negative, but then this is also negative because it's losing heat, it's losing energy. Okay. So then it's going to be this whole thing right here, which that's going to be a negative 600. Try to get a spot that's not so glary here. Negative 679.9 divided by 0.390 times 2.5. Okay, that's 600. Oops, I just forgot. That's actually going to be a positive because it's going to be that negative times another, like basically times -1. So that's actually going to be a positive 697. Be 697 plus 22.5, which ultimately tells us here that the initial temperature of that zinc was 720 plus a decimal, 720 degrees Celsius initially. Okay, now make sure that when you complete this guy and then this guy, keep in mind the specific heat of water, 4.184 joules per every 1 gram by 1 degree Celsius. So remember that. Also, the final temperature, final temperature here is going to be the same final temperature of the water. So when you heat the gold up and then drop it in the water, the final temperature for the gold is also going to be 20 degrees Celsius. So keep that in mind. This one don't have to worry about that because you're specifically solving for the specific heat of aluminum. Okay, but you're roughly going to do the same thing that you did up here. You're just going to end up using a different equation at the very end over here. So anyway, that is what we're doing today in class. So that's all I have for you guys. If you still have any questions, get a hold of me.